Alright guys, today is basically the same thing as yesterday, but we can't really use the less than greater thing because we're going to be using, we're going to have a negative coefficient in front right here. Less than or greater works only with positive. Okay, but if I just want to solve this by graphing it, again, put this into your y1, put this into your y2, and let's look at what the calculator should look like. It should look like this when you graph it. Then what you have to do is, again, second trace 5 and get those values of where they intersect. Enter, enter, enter. Because those are the points you need. So negative 1.123. That is one of the things I need. So I'm going to sketch this real quick. These are going to be open where it hits. And the graph look like that. Okay, so this is negative 1.123 comma 0, and if you do the other one, you should get 7.123 comma 0. I need to see these points, and then you can either do a test because we don't have less than and greater, or just think about it. Where is this function greater than 0? Look at the curve. Where on the curve is the curve bigger than 0? Between this point and this point. And you could always double check by putting in a 0, 0, because 0, 0 is a fine test point. But just look at it graphically. The graph is higher than that. Now, some of you guys might be wondering, why did I not dot the parabola? Because I'm not really using, this is not graphing the parabola itself. I graphed the parabola, but the answer is really this. And where this less than or equal, or less than or greater than symbol comes in are these dots. These dots need to be open because of that. Parabola doesn't matter, don't care about that. I just used it to help graph and find my solution. So this is how you do it graphically. You graph it, find your two intersection points, and then look at it. Where is the function greater than 0? Well, the function is greater from here to here because it's above 0. So between these two x values is my answer. So to write it as an inequality, the lower bound is negative 1.123 to x to 7.123. So this is the, I want it in with an inequality, and I want the graph. Alright, that's how you do it graphically. Now algebraically, you don't need to graph at all. You just have to factor. Whenever you see the words algebraically, just think you have to factor it. So first thing you got to do is move over that 2. Okay, now you can use splitting the middle term, Batman, whatever you want to call it. I'm going to just do guess and check because these are small numbers. So we know it's going to be a 2x and an x, so to get a 2x squared. And to get a negative 2, well, it has to be either a negative 1 or a negative 2. I'm guessing the negative 2 goes here, so I get negative 4 here, and then a plus 1 gives me a positive 1. That gives me my negative 3, and I did it. Okay. Again, if you can't see that by guessing and checking, then use Batman and do it that way. So I have my number line, which I'm going to put here. My critical points, I have to get my critical points. I didn't do that yet. 2x plus 1 is equal to 0, and x minus 2 is equal to 0. Again, think about this in terms of the graph too. I'm basically finding where it hits 0. Just like up here in the graph, I was finding these two zeros, but we're doing it with algebra instead of the graph itself. So we get x is equal to negative 1/2, and here we get x is equal to 2. So I'm going to just plot negative 1/2. I always put 0 on here just because, and then 2. Now, these are both going to be filled in bubbles because they are equal to those points. We have the equal symbol here. Now we just have to figure out which way it's going. You have to test each region to figure that out. Okay, I'm going to use x equals negative 1 here. And again, I need to see all this work. X equals 0 and x equals 3. Over here, when x is negative 1, I get 2 times negative 1 plus 1, and negative 1 minus 2 is greater than or equal to 0. So we get negative 2 plus 1, that's a negative 1, times negative 3. Negative 1 times negative 3 is positive 3, which is greater than or equal to 0, which is true. So this is a true statement, so I'll put a check mark there. In here at 0, we get basically 0 plus 1, 0 minus 2 has to be greater than or equal to 0. I'm just plugging zeros in for x. 1 times negative 2, you should see, is not greater than 0. That's false. This is true. And finally, we can put a 3 in for x. 2 times 3 plus 1, so it's positive. And the other one is also positive, 3 minus 2. So this whole thing should be greater than 0, which it is. So it's true. So my final solution would be this, and to write that as an inequality, x is less than or equal to negative 1/2, or x is greater than or equal to 2. Again, this is an OR graph. Don't say and, because and means they intersect. Okay, and that is it. That's how you do those two. Alright, so now we just have word problems. Okay? You're building a wood case. A wooden bookcase, I should say. Not a wood I don't even know what a wood case is. But you want to choose a thickness, D, for the shelves so that each is strong enough to support 60 pounds of books without breaking. So, it says graph the inequality. Well, we know that W has to be less than or equal to 300d squared. So you can think of this as y 300x squared, okay, if you want. When you graph this inequality on your calculator, just put this is y2, or y1 I mean, just put this as y1, and then graph it. This is going to be a solid parabola. Now you're going to have to fix your window to look at this, but it'll end up looking like this. There's a 0, 0, and it says graph the inequality. So we want to shade somewhere, okay? Well, I'm going to try the point 0, 1. I'm going to test 0, 1, which is saying that if the thickness is 0, it could support a weight of 1. Right away, you guys should be able to tell me if that's true or false, okay? But let's think about it in terms of this. So the weight is 1 less than or equal to 0? No, it's not. False. Since I shade false, it means that anything in here will not work for my shelf. And actually, anything over here probably wouldn't either. We probably should be just looking at quadrant 1 itself, actually. But because really, are we going to be dealing with negative thicknesses? No. Okay? So really, anything will work outside or on this line will be a solution to this. Alright, so if you make each shelf 0.75 inches thick, can it support a weight of 60 pounds? Well, let's see. If I have a weight of 60, is that less than or equal to 300 times 0.75 squared? When you solve that, you get 60 is less than or equal to 168.75. So yes, it can. It can support it. It is true. Again, so we're just using the same thing we did actually in the last lesson, where you're just graphing a parabola and shading it the correct way and then answering a question about it. Okay, nothing really new there. Just be careful with working with your window. Try doing that on your calculator. Alright, so now this one's going to be kind of the same thing. We have a study was conducted to test the average reading comprehension of a person X years of age. Study found that the number of points scored on a test could be modeled by this quadratic. Now it says between 5 and 95. At what ages does the average person score greater than 60 points on the test? Well, first thing I did would be to graph this in your calculator. Okay, so I'm going to show how it looks. When you graph that quadratic, looks something like that. Okay. Now, the thing that matters, it says, what ages does the average person score greater than 60 points on the test? So this will be your Y1. And then in Y2, you want to put 60 in your calculator. So what it's going to do is draw this line at 60. Okay? So what you're looking for is these points. Okay? So why don't you guys look at that real quickly, see if you can come up with those two intersection points. And when you're done getting that, it should be 18.240, 60 is that point. And for this point over here, we get 93.525, comma 60. So what that's telling us is, what ages does the average person score greater than 60 points on the test? Well, the average ages that it would have to be between is 18.240 years, and between that and 93.525 years. Now, let's just ask ourselves a quick question up here. It says x is between 5 and 95. Think about why that would be our domain for this problem. Those ages. Okay? Let's take a second to think about that. And hopefully you guys realize that, you know, usually they're not testing reading in a 2-year-old because they can't read. Okay? So they decided to start this study at age 5. Okay? And then 95, there's not a lot of people left after 95. So they went to 95 just to see what that was their cutoff for the test. They obviously aren't going to test people up to 120. There's very few of those around. So that is why that domain is 5 to 95, because that's usually the age span that we can look at. So this would be the answer. I would need the graph and then the answer there, and then any critical point that would be part of the problem. Alright, you don't have to do anything really here, just think about this. Special cases for solving graphically. So if I graph this, okay, it's saying, where is this u less than 0? Where does this u go below the 0? Hopefully you guys see that it doesn't. It's up here. This would be a no solution. It never goes below 0. There's no part of the u under there. Hopefully here, this is saying, where is this function above 0? Well, look at the graph. It's above 0 all the time. So this would be all real numbers. Okay, so if you ever get a graph where I'm telling you to solve it graphically and you get something like that, that's, you know, just look at it. Now this one's saying, where is it less than or equal to 0? Well, less than, there's nothing really. Equal to 0, there's one spot. There's going to be one solution here. And it's the vertex. Here, it's saying, where is this greater than 0? Not equal to, so it can't be equal to 0, but greater than 0. Hopefully you say it's every single value for x, because look at it's going up forever here and up forever there, so every x value, except for you can't have it equal to 0. So it's x cannot be the vertex. So it's kind of the opposite of the last one we just looked at. So there's just some special cases. Alright, but again, nothing really new today except for just using our quadratic inequalities to graph and find our information that we need. Alright? Alright, well then I will see you guys next time we meet.